Please welcome Shikma Litmanovitz, Technion, Israel Institute of Technology.
Hi, my name is Shikma Litmanovitz, and my mission has always been to cross boundaries and build bridges between academia and industry. Today I'm deeply honored to nominate Ceal Minerals as the Science Breakthrough of the Year 2025. Why Ceal? Because I embody the power of science to change the future. Born from the pioneering research of Professor Charlotte Wort at the Technion, Ceal Minerals has created the most energy-efficient technology for removing carbon dioxide, and they are ready to scale it to a level the world has never seen before. Their innovation transforms CO2 dissolved in seawater into essential minerals while providing soft water that can serve communities and industries alike. This solution doesn't just reduce emissions, it tackles marine pollution and reimagines how industry can coexist with our planet. Ceal Minerals shows us that breakthrough science can also be a breakthrough for humanity. With a vision, we are not only addressing climate change, we are taking a bold step toward reversing it.
Breaking the wall of power plant and mining pollution. Marty Shani, Ceal Minerals.
Imagine a world where power plants not only avoid harming the environment, but actively help clean it. That is Ceal. We reduce the carbon footprint of power plants cooled by seawater while also increasing their efficiency. Every year, each power plant loses $3 million. Their pipes are blocked by biofouling and Ceal, cutting efficiency. So they use hazardous chemicals to reduce buildup. But these pollute the oceans and don't help. You can see it in the picture. A blocked pipe before its maintenance. And of course, fossil fuel plants also emit a lot of carbon dioxide. Our technology works with any thermal power plant, including nuclear. Our system turns the calcium and carbon dioxide in seawater, the sources of biofouling and Ceal, into solid minerals and creating two output streams. The first calcium carbonate, calcium depleted water, perfect for cooling, no more clogging, no more hazardous chemicals. The second, precipitated calcium carbonate, also known as PCC, an essential industrial feedstock with a $40 billion market. Please remember the power plant you see in this picture. For an average size 1 gigawatt power plant, Ceal delivers every year $3 million in OPEX savings, 500,000 tons of carbon dioxide sequestered into 1 million tons of PCC, which generate $100 million in PCC revenues, and at zero marine pollution. All these benefits without relying on carbon credits. There are 1,100 power plants cooled by seawater globally, a huge market with a gigaton carbon dioxide removal potential. We create an end-to-end win-win-win industrial value chain. Ceal delivers a tailored design reference to the power plant. The plant then engineers, purchases, builds, and operates the site. It owns the produced PCC and enjoys an incredibly short return on investment. The industrial mineral producer offtakes the PCC and processes the end applications. They benefit from cheaper carbon-negative PCC. Ceal also provides maintenance and consumables and collects royalties on PCC revenues. It is a capex-light business model for Ceal, enabling rapid scaling. We're talking with 7 utility companies operating 79 power plants cooled by seawater. One of them, the Israel Electric Company, invested in Ceal and signed a contract to deploy a funded pilot next year in the power plant presented earlier. We're also talking with 4 industrial mineral producers confirming PCC demand. We run a TRL-5 pre-pilot prototype using real seawater. It is the basis for next year's pilot. We see connections to European utilities to host our first pilot in Europe. We're protected by 4 pending patents based on our experiments and promising results. Seawater, electricity, and air are all we need to operate. We do not require chemicals nor any other additives. Only Ceal delivers high-quality minerals, reduced carbon footprint, and sustainable water treatment in one process. We outperform legacy water treatment solutions with a green and a more effective solution. We outperform other carbon removal technologies with a more energy-efficient system. Ceal's technology was developed at the Technion, Israel's Institute of Technology, by Dr. Charlotte Vocht, co-founder and lead scientist. Dr. Shani Hershkovitz, co-founder and CTO and industry expert in electrochemical catalysis, takes the technology from lab to product and to scale. Anat Greenland, Chief Business Officer, turns our deep tech innovation into business and regulatory growth, drawing on her legal, finance, and VC experience. I led multiple design wins and the development and selling of complex deep tech systems that require a long sales cycle. Our passion, turning climate problems into profitable business. Finally, the beautiful view from our office, a reminder of why we do what we do. Thank you for your attention and the opportunity to pitch. Happy to take your questions.
Thank you. Okay, so now we can be ready for the 4 minutes for the Q&A. Thank you. We have a first one here. Second, Iris. Yes?
Thank you. So the electrochemical cell, which processes the seawaters first, how durable it is, and is it also prone to all the problems which you showed just with the pipe, with the clogging, etc.?
So the process is divided into 2 steps. First, there is electrochemical process, which we create the conditions for calcium and carbon dioxide to precipitate. It's a supersaturation state. And then we have a separate process step, which is mineralization. The water is ready for saturation, and there's precipitated outside of the electrochemical cell. Does that answer your questions?
Okay, so let's move to the next question because we are building for sure. Yes.
Thank you. How do you make sure that only the calcium precipitates and not all the other minerals present in seawater?
Perfect question. So the process is very selective. There is a fine window where only calcium, actually also boron, but boron is a very, very low concentration, precipitate. Magnesium is at a different state. Basically, we raise the pH to a very specific point, and we already checked that we have a very pure mineral.
Okay. I don't see any question from the jury. Otherwise, I will take one from the audience. Can we have a microphone here in the 3rd row, please? Thank you.
I wondered, what do you do in the future where all our energy is produced by solar and wind?
Well, give me the estimation of how long it will take to all power plants to... and as I said, we can work with nuclear as well. It's not going to be anytime soon with all the AI demand, and power plants are built today as in the past.
Yeah, okay, we have the next question here in the 1st row, please. Thank you for the microphone.
I think you said your business model does not depend on carbon credits, but then why are you not monetizing them?
I didn't say we're not monetizing. It's not there, but mainly we want to show that we're very profitable without carbon credits. We actually have 2 sources for that, if I have time. Yeah, so one is we're actually reducing the emissions polluted by the limestone industry, and they're extremely polluting, so we have scope 3 on that. And the water that we're emitting has a higher buffer in terms of absorbing carbon dioxide. So we'll be also doing, so it's a carbon capture and a carbon removal in one process.
We still have 1 minute 20. Sorry, I don't see. Oh, here, sorry. We have a comment here in the last row.
Yeah, a comment regarding the production of energy. It's not just power plants that have scaling issues, also large-scale data centers using liquid cooling, where scaling is a real issue. So I think that could also be a game changer there.
Yep.
Nice comment. Thank you. We still have 1 minute. Yes, Milena, please. Thank you.
So what is your target market? Mostly the
power plants.
Power plants.
Power plants,
right.
Cooled by seawater. We just want the most massive industry that uses so much water.
And then do you see any other application after that?
Yeah, it's before that, actually. In order to get the scale to power plants, we will stop at earlier or easier industries that simply use less water, such as cement and steel. Some of them are located on the...
And they are one of the biggest energy.
Yeah.
Okay.
The only thing is that we need seawater, so they need to be located near the shore. There are many refineries, oil and gas rigs, by the way, shipping. we're approached by shipping as well. So
Thank you.
Thank you. I think we won't have any further questions in 6 seconds. So thank you so much for this.
thank you very much.
And